Hello, this is Mark. This is video number 3. We're still going with the basics on the schematic. So let's get this opened. Again, we opened the PRO thing to get started. Bring up the schematic. This is where we left off. And, I can close this off here because that just, let's see here. Let me just shrink that down a little bit. Okay, that'll give us a little bit more working space. Okay, so here's where we left off last time. We're, nearly done with this. We've got a couple of things here. We've got the SW clock and SWD lines that are here. When you're doing development on the RP2040, one of the big challenges or the big complaints that I have is when you compile a program, you don't want to have to unplug the USB and plug it in every time. And if you're using the Arduino environment, they get around it, but that's got other side effects that I'm not really interested in at this point. You can actually program it through the JTAG interface, which is the S clock and SWD lines. So I like to put it doesn't take much space on the board, so I like to put a 3-pin connector on the board for that. So let's just drop one in there. So I can come back and let's drop a connector in there. I want a connector. No, I want a connector generic. And it only needs 3 pins. That'll look just fine. And I'm just going to put this in here. It almost doesn't matter where I put it because all I'm going to do is I need these 2 data lines connected into it, and I want to match what I've done in the past. So let's see here. Look at this in here a little bigger. So I'm going to do the Command D to duplicate the clock, and I got the clock line on pin 1 on my other design, so I'm going to continue that here. Notice when I placed it in there, the little circles went away again, and then the SWD line, I'm going to put that on pin 3, and I'll just stick it right on there. And pin 2 needs to be connected to ground. So here's my ground, and I'm just going to stick that out there. And then I'm just going to draw that in there. Okay. So in maintaining how we've done other things, I need a footprint for this. I like... For all of the simple connectors on here, I tend to use the 10th-inch center connectors. And if I click on Assign Footprints, we get this one is blank. And I'm going to say connector, I got all sorts of pin header. And I want pin header 2.54 millimeter, which is 1/10 of an inch. Okay, so I'm going to select that. And I want... the 1x3 P2.54 vertical, not the SMDs. I'm grabbing things that I know I've got in my toolbox and of parts. So I'll do that one. And the verticals take up less room. And does it matter whether it's going to be pins or sockets? At this point, no. It's going to be a row of holes that are just 1/10 of an inch apart. Okay, so that's been assigned now. We're still missing the entire USB interface stuff. So let me zoom that back out a little bit. Let's grab a connector, and I want a USB connector. And let's see, where the heck did we put those? Connectors, generic audio. Let's just look connector and see if we got something in here. Connector, RST, USB-C, and we're using this USB-C receptacle, USB 2.0_16P, 16 pins. This is the connector we're actually putting in there. And let's see, can we assign the footprint here? Let me look up which one I use because I want to make sure I use the correct one. Let's see here. You know, I'm not sure which one that is. I'll have to look that up because it's not in my other list, but let's see what this looks like. No, that's not it. It gives us a photo, and so that's always kind of nice. And I need the... That looks correct. Let's see here. Is 16p. I think that's the correct one. I'll verify that before we go too far. So that looks like that. And let me just drop this in here. And I'm going to keep it clear up in the corner. And let me hit the escape key. Okay, so here's the USB receptacle that needs to go on there. Some of the lines are pretty obvious. I want to connect the shield and the ground. Those get to connect together. So let me just do that. And I just want to duplicate my ground. And I'm just going to put that there, draw lines. Okay, so those two are grounded. The V bus that ends up being our 5 volts out. Let's collect everything else first. I need the D minuses and the D pluses are actually connected together. And so I'm going to connect this like this. And I'm going to put a flag on it. And it's going to say, I'm going to say D minus, DM for D minus. And I'm going to set it right there. And then these are the actual USB symbols or signals that we use. And I'm going to do the same thing down here. And let me just duplicate that. That's just as easy. And then I want to edit that because that's not DM. That's the DP for D plus. Okay, so this is the D minus and D plus. Now, the microprocessor, this is USB DP D minus, and that's exactly what we think it is. So let me zoom in just a little bit there. Let me duplicate this, the D minus, rotate it, and just stuff it right on there. And the D plus, we do the same thing. 2 R's to rotate it around and set it there. So there's our USB signals. Oh, we don't really want to connect them straight. Actually, we need a resistor in line. So let me move these. Let me move these over. I need a resistor in line. I'm getting ahead of myself. And let me get a resistor. And what we really want is 27 ohms. So let me just put something in here like this. And let me edit the value and say 27. Duplicate that. And then draw these lines in. I got these labels on top of each other. I don't really want that, so let me move one of them around. So this is R6. Let me put it up here. Now, if I put this right here, it looks like R627. But if I put it on this side and then move the 27 over here, you can tell that this is 27 ohm is R6. And I'm going to move this to the same location just so we can make sure that we keep it separate. Actually, I'm going to put it on the bottom like this. If I do this as I go along, then it's not quite as confusing later. Okay, so there's my 2 resistors there. Now, USB-C is kind of an interesting beast in itself, and, you know, I certainly don't understand a good chunk of it. But when you plug this into a smart thing like a computer or something like that, these CC1 and CC2 actually tell the system what it is. And we need 5.1K resistors to ground on both CC1 and CC2. So let me make those. Let me duplicate a resistor because I need that. And then let me edit the value. And this is 5.1K. And then let me duplicate that. Yeah, I know. We're going to have this thing here. And then the labels get in line with everything else. So let me see. What do I want to do with that? I can move the whole thing out a little further. So let me just do this because I'm going to get the labels in the way otherwise. And I can just swipe a circle around both. And let me just move them out. Just so I can get the labels down below. And then I'm going to move the labels. Oop, no, I don't want to loop everything. I just want to move that one label. Okay. And I'm going to do the same thing here. Okay, and both those need to connect these lines to ground. So, and that's the only places they go. So let me just type those in here. That there, and I need another ground. There's one. And okay. These two lines, we don't actually use them. Now, the computer's going to complain if they're not connected, if we don't say that that's what we really wanted. So over here is a little X that basically says that we're intending to leave these not connected. That'll prevent us from getting that error message. Okay, so now let's see. Now the power for this entire thing comes from the USB cable, and that comes in on the V bus, and that's going to be a 5-volt line. And we need to put, you know, if we end up powering it from something else, we certainly don't want anything powering it back. We could just ignore it, but I'm going to put in a Schottky diode just for protection. So let me go back here and let's close that off. Let's see, what do we got? Diode Schottky. Okay, there we go. And that's rotated the wrong way, so let's go to this way. So this is our Schottky diode. Oh, we do need to, what is this thing? We do not have a, I need a package for this. So let me assign a package while I'm at it, just so we can do it. Diodes, SMD, and we're going to put in here I think it's an SMA diode, let's see here, various sizes, SMA. Let's put an SMA diode. Again, I'm going for ones that I've got in my collection. And if I have a big problem with it, I'll notice it when I go do the board layout because I know what it's supposed to look like. Okay. So let's start there. Okay, so this is going to be 5 volts over here. And if we want to use 5 volts, this is where we tack it from. But the processor needs 3.3 volts. So we need a regulator for that. So let's stick a regulator in here. And again, so we need another part. And the one that we've got is the AMS 1117. AMS 1117 3.3. And it's actually got the package already. It's a SOT 223-3 package. So if I say that is what I want, that's our thing, and I want to put it up. I want the line just to be in line with that, because then I can just do, oh, let me move it over just a bit further. Because I can just do this. Oops. I need a ground. And I'm going to just put it down. I'm going to put it really low for a reason. And I need caps on both the inputs and outputs. It's not real picky about how much capacitance we're going to put there, but I'm going to go for, you know, the 10 mic will probably just be fine on both input and output. Okay, so we'll just do that. And let me zoom in on this. Okay, so I'm going to draw these in. Okay, now this is actually our 3.3 volt output. So I could draw a line over to here and connect it, and that would be adequate. But I kind of like to keep things on my designs a little bit separate. So I'm actually just going to put a 3.3 volt tag and just draw that in. Okay. Let's see. What else do we need? I think we've got everything we need to make it run. So this is, if I were to design the board up with this set of parts on here, I could program it, I could talk to it through the USB, but it's pretty boring. But this is where, you know, I want you to start thinking about how to make the board your board and how to make things different. The one thing I do want you to put on here, though, is I do want one LED. It's way more fun if you could at least make the board blink to say that it's running and stuff like that. So let's add one LED before we quit this video. In fact, we'll actually start the PC board layout just to get an idea if everything looks kind of normal. Okay, so I want a device, and I want to clear that out because what I want is I want a diode LED. Devices, I think it's under devices. LED, okay. And I just want a generic LED. Okay, there's an LED. And I'm going to put it on the pin 2 here, the GPIO 0 line. And I'm just going to put it right there for now. And I need something to limit the current. So I need a resistor. You know, if I grab this one, it's the value's already okay, because I want a 1K. So I want to duplicate the 1K resistor. And I'll put it right there. And then zoom into this. Oh, and we need a ground, so duplicate that and just set that right like that. You know, I'm concerned that when I do this, then I'm going to be in trouble with the other line. So let me just take this whole piece and move it up. I didn't get the ground. That's okay. We'll get it. Because there's nothing else going up here. Let me put this up here. And then let me, if it's moving more than you want, you can hit escape and it'll get things out of there. Let's move this up to there. Okay, let me draw the lines. Okay, I've got my one LED. There's something called a design rule check that is really an important thing to run. Electrical rules checker. Let me run that. This is something that's good, and I'm going to get this gazillion error pin not connected because all the microprocessor lines are not connected to anything. But there are 3 other lines here. I get this error input power pin not driven by output power pins. And I get 3 of those. I expected this. I've done this before. Now, on the schematic, if I just zoom in anywhere, it doesn't matter where, and then I click on this line, it will take me to that spot on the schematic where it's having this issue. And the problem is that it knows that this A4 pin is an output. And it knows that this pin 3 on this regulator is an input, but there's this device in the way. So it's not sure that that is correct. Now we can tell it that it is just fine by adding another part. Let me just close this for a moment. We'll run it again in a second here. And I could add, I'm going to click the little power symbol and back to power. And there's something called a power flag. And it is really, it doesn't tell you, it's not going to connect anything to anything. But what it does is it tells the computer that, no, this is fine. So I'm just going to put it there. And then I'm going to run trace from there to there. So that's all I've done. I've just added this power flag. Now, if I rerun this error check again, that error message goes away. I've still got a few more of the exact same thing. So let me click on this one. Okay, so here's the A to D converter input, power input. And it knows that this is a power line and it would be fine, but I got this 100 ohm resistor in line that's causing it grief. So if I just put another power flag in there, it'll be fine. So let me grab this one. I'm going to duplicate it. That's always the easiest way to do it. And the question is where can I stick this where the labels don't get over everything else? Let's see here. I'm going to put it over here because that shouldn't interfere with anything. And I'm going to draw it this way. Okay, so that'll fix that one. And there's one more that is the ground lines. It doesn't really know where the ground line is. So I need a ground line somewhere that has a power flag on it. So let me go back, zoom out. And we've got lots of places we can put those. So any ground line we can put it on. So if I just duplicate the power flag, I could put it down here. And then I can draw this in. Now when I run the design rule check, error pin not connected. I think that's all that should be in here. Yeah, all of them are error pin not connected, closed. Okay. So what we've got is all of these saying not connected, which is they're not connected. Okay, so we will fix all of that. But this is a really good place to stop. This is what every board should have on it at this point. And from now on in the future, then everybody gets to deviate from this design. In fact, I kind of require it because I want your layout to be different than mine. So I'm going to save this work and pause the video here.